Hey class, this is the second half of the Chapter 16 AP problem. So what I'm going to do with this problem here is I'm going to treat it kind of like, let me get on, there we go. I'm going to treat it kind of like it's an ice problem, but I'm not going to use molarity, I'm going to use moles, and I'm going to use the ice format to figure out how much moles of one thing react with moles of another. So let's calculate the number of moles of HF remaining in the solution. I can do that up above here. So the number of moles of HF remaining in the solution means I need to know the number of moles of HF and NaOH before we get started, because I'm going to use that information. So let's do that first. So up here I have NaOH. I have moles equaling to concentration times volume. Now where did I get that from? I'm hoping that you have seen like this formula enough times to know that molarity is equal to moles divided by volume, and if I'm solving for moles here, that means I divide both sides by V, and that moles, that's what gives me this right here. So let's do this one first. I have to change for the volume though. Volume must be in liters, which means that I'm going to move, for the first one, it's going to be 15 milliliters like this. I'm going to move the decimal place 1, 2, 3 places like that to get my number of liters, so 0.015 liters. Okay, so that's how I have to do all that. So that means that my molarity here is going to be 0.4 like this times 0.015 liters like that. So when I multiply those two, I get 0.4 times 0.015 gives me 0.006. So the number of moles I have of this is 0.006 moles of NaOH. Now let's do the same thing in a different color for HF. I'm going to do exactly the same calculation, is just like that. So that means that moles equals, again, 0.4 molarity times, and then I'm going to change the 25 to 0.025 liters like that, and that will give me 0.025 times 0.4 equals 0.010, like that. Okay, so that's the number of moles of HF. Good. Okay, now I come down to this right here. Come down to, oh boy, there we go. Now I'm starting off with 0.010 moles. Move that over a little bit. Come on. There we go. Now notice that for the moles of NaOH, I got 0.006. So which one's larger? Obviously the HF is larger, so there's going to be more of that left after we subtract the two. So I subtract 0.006 from this side and 0.006 from this side, and what I get then, of course, is 0. So this is my initial moles, this is my change in moles, and this is what I get after the moles react, or equilibrium. So that means that for the number of moles I have of HF, it's going to be 0.0040. That's the number of moles of HF. Notice that I've got 0 moles of OH for right now, and then over here I start with 0. Well, I always have some of this, that's not even my consideration. I start with 0, and then I add 0.006 moles of this, and what I'm left with then at equilibrium is 0.006 moles of that. Okay, so here's my problem. My problem is that now that I have this figured out, notice, that for both of those, finding the number of moles for this one and for this one, I have a volume. So for HF, the volume was 25 milliliters. Notice that for NaOH, the volume was 15 milliliters. When I add them up total, okay, my volume for this then is, of course, 40 milliliters. But that equals 0.040 liters. So this is my total volume. when I add the two solutions together. So if I'm going to do this, now notice this. Notice that once the HF is added to the OH, there's no more OH. Okay, so now I have a certain amount of this and a certain amount of this left. And we always have water. Okay, so what I'm going to do is I'm going to divide both of these by 0.04, like that, and 0.04, like that, for the liters for both of these, and then that will give me a concentration of HF that's left over and a concentration of F minus that's left over. So 0.004 divided by 0.04 equals 0.1. Okay, so the amount of concentration of HF is that, and 0.006 divided by 0.04 is 0.15. And that's the concentration of F minus. Okay, that's going to become important. So this says calculate the pH. Oh, first of all, let's go back up here and answer these questions. Number of moles remaining in the solution will be 0.0040 moles of HF. Good. The calculate the molar concentration of, okay, so that's going to be 0.15 moles of F minus. Good. Calculate the pH of the solution. Now I have to do an equilibrium problem. This one's not too tough though. So let's go back down here. I'm going to need some room for this. Whew, that took a while. Okay, so that means in a different color now, I'm going to do the last part of this. That's going to be HF again, equilibrium, H plus, which is the one I'm looking for, plus F minus. Okay, my ice, my initial conditions are 0.10, 0, and 0.15. This is a little bit different of a problem because we're starting with some of the product, okay, which does change things. So I get a minus x, I get an x, and I get here, oops, a plus x. So I get a plus x and plus x for that. My equilibrium is, of course, going to be 0.1 minus x. It's going to be x, and this one's going to be 0.15 plus x. Okay, now here's the cool part about this. When I separate the weak acid here into the concentrations of H plus and the concentration of H minus, like this, all divided by the weak acid HF, like that. I'm going to substitute in what I have, but here's the cool part. As always, which is why I love Chapter 16, I can get rid of the plus x there, and I can get rid of the minus x there. They're gone. Okay, so now I go back and plug everything back in the way it was. So that means x times 0.15, like this, divided by 0.1 equals, and then I go back to, I think what I have is 7.2 times 10 to the negative fourth is my Ka for this. Let me go back down to the bottom here. Come on, all the way back down to the green. All the way back down. I need a little more room. There we go. So all of that equals 7.2 times 10 to the negative fourth. Okay, so I multiply by 0.1, divide by, so that's what I'm going to do on my calculator. Multiply by 0.1, divide by 0.15 equals, so my x here equals 0.00048, like that. It's asking for the pH, so pH is equal to the negative log of 0.00048, like that. So I hit the log and hit the plus minus, and I got my pH is equal to 3.32. There's my answer. Excellent. Thanks for paying attention.